Okay, so I'm Ritwik and this is chemistry section. Yesterday, that was one part of chemistry and half of the part. Today, it's the half of the second part and third part of the section, uh, electrolytic solutions. And you're gonna have additional topics, batteries and solution. One's the important means the in this it's electrolytic solutions. Solution to ultralight concentration to your uh, molar conductivity and conductivity vary. That's one thing we didn't cover yesterday. Basically, conductivity always decreases with decrease in concentration, both for weak and strong elements. Conductivity is basically like conductance per volume. So if concentration tagte, your number of uh, moving charges tagte, so conductivity is uh, separate. Molar conductivity is solution at a given concentration. That's the definition. A given concentration is conductance of the volume E of solution containing 1 mole of gap between two electrodes retained of section A and distance of E. That's the definition. Molar conductivity increases with decrease in concentration. It is molar conductivity is equal to conductivity A by L is so this is so it means kappa or with decrease in concentration your kappa decreases but your volume increases so molar conductivity like చెప్పలేము అనిపిస్తుంది but experimentally seems decrease in kappa is much lesser than increase in volume so your molar conductivity increases with decrease in concentration. This is the graph for weak electrolytes. Weak electrolytes vary in this way with respect to concentration power 1 by not this is for strong electrolytes. The power that should be a straight line. Which is also near x and y axis. I'm trying to like say you cannot have absolute zero. You can have absolute zero concentration. అక్కడ like the graph is like when the concentration approaches zero, not exactly zero. You cannot have that split. Uh, this state is called limiting. అక్కడ extra you అక్కడ they didn't measure the graph. ఇక్కడ మధ్యలో points కి they measured it and turned out to be a split. So strong electrolytes की the straight line. This is for strong electrolytes. This is the equation. Divide and answer equation. Name also. Divide hook. So essentially, molar conductivity is limiting molar conductivity minus A into C power 1 by 2. A is like electrolyte dependent. Is the pair of the electrolyte and the solution and the ions pair dependent. This here is the limiting molar conductivity. Limiting in the sense approaching maximum value. This value is limiting molar conductivity. So this is molar. This is for strong electrolytes. This is for weak electrolytes. Weak electrolytes key the graph is like messy as shown above. So we cannot have like molar connectivity in some law to determine cheyalepoyindu. But what is possible was weak electrolytes limiting molar conductivities ki we have a law, Kohlrausch law of independent migration of ions. This is this the proof of this law arises from theory, not experimental. So electrolyte and a weak electrolyte and a strong electrolyte and your limiting molar conductivity is the sum of limiting molar conductivities of its cations and anions. As given below, NaCl ki it's sum of lambda naught Na plus lambda naught Cl minus. For the NaCl, you'll have like that delta thing, trying invert V thing. Ions ki you'll have lambda as representing the molar conductivity. So if NaCl ki that's the law. So MgCl2 it's like lambda naught MgCl2 Mg plus 2 plus 2 into lambda C minus. So అట్లా 1 mg plus 2 ఉంది కాబట్టి ఇంటూ ఇక్కడ 2 equal to 2. These are like molar conductivities. Limiting molar. The law is so the law turns out to be equivalent conductivity of the electrolyte equal to equivalent conductivity of cations plus equivalent conductivity of anion. Like 1 into 1 into and 1 into. Equivalent అయితే there is no need of the multiplying with 2 and all. equal molar అయితే you have to multiply. Uh, for weak electrolytes, the degree of dissociation is uh, the degree of dissociation is molar conductivity by equivalent molar conductivity, like limiting molar conductivity. Shown here. But we know for weak electrolyte like acetic acid, Ka is C alpha squared by 1 minus alpha. So when you replace the alpha, you can have this formula. So how is Kohlrausch law useful? For determining the Ka of weak electrolytes, alpha of weak electrolytes. On conductivity rather, but we can have some useful information out of Kohlrausch law. That's the end of electrolytic solutions thing. Now electrolytic cells reverse basically when you ఒక రియాక్షన్ రన్ చేస్తే ఈ గ్రేటర్ దెన్ జీరో ఉంటే డెల్టా జీ లెస్ దెన్ జీరో ఉంటుంది స్పాంటేనియస్ రియాక్షన్ we can draw power from those అని చెప్తాము electrolytic cells is when a reaction won't happen spontaneously you supply energy in form of electricity and push the reaction to move in forward direction. So basically E less than zero ఉన్న reactions cell reactions కి you use electrolytic cell. It needs power and ఈజీ చెప్ప ఎందుకంటే దెర్ ఇస్ ఎన్సిఆర్టీలో అంత కాంప్లికేటెడ్ గా వెళ్ళలేదు. ఎలక్ట్రోలిసిస్ ఎలక్ట్రోలిసిస్ ఫాలోస్ ఫారడేస్ లాస్ ఆఫ్ ఎలక్ట్రోలిసిస్. టూ లాస్, ఒకటి amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. బేసిక్లీ ఎంత కరెంట్ ఇస్తే దానికి ప్రపోర్షనల్ గా లైక్ నాట్ ఎంత కరెంట్, ఎంత అమౌంట్ ఆఫ్ ఛార్జ్ ఇస్తే దానికి ప్రపోర్షనల్ గా అమౌంట్స్ రియాక్ట్ అయ్యి ఐదర్ దే డిపాజిట్ ఆర్ గెట్ లిబరేటెడ్ ఆర్ గెట్ బ్రేక్ ఇన్ అవుట్ సంథింగ్. లైక్ ఫర్ సపోజ్ ఒక రియాక్షన్ లో యూ హ్యావ్ యువర్ ఎలక్ట్రాలిసిస్ ప్రోడక్ట్ యాజ్ ఏ ప్రెసిపిటేట్. సో ఇప్పుడు నువ్వు 1 కూలుంబ్ ఛార్జ్ 1 ఫారడే ఛార్జ్ ఇస్తే మేబీ some 5 grams precipitated. When you give 2 coulombs, 2 Faraday's charge, you will get 10 grams precipitated at that altitude. I'm not showing you the electrolysis cell, my bad. Second law, the amounts of different substances liberated by same quantity of electricity passing through this electrolyte solution are proportional to their chemical equivalent weights. True, right? So basically, 1 Faraday is 96500 coulombs. It is like charge of 1 mole of electrons. ఇప్పుడు ఆ అమౌంట్ ఆఫ్ ఛార్జ్ నువ్వు సెండ్ చేస్తే ఇట్స్ లైక్ 1 ఈక్వివలెంట్ ఆఫ్ ది రియాక్షన్ ఇస్ హ్యాపీ. సో ఇప్పుడు రియాక్షన్ లో మనం రాసే కెమికల్ క్వశ్చన్స్ బట్టి ఇట్ కెన్ బి 2 moles ఆఫ్ ఎలక్ట్రాన్స్ ఆఫ్ ఛార్జ్ ట్రాన్స్ఫర్, 3 moles, 4 moles చెప్పలేం. సో బట్ రియాక్షన్ క్వశ్చన్స్ ని బ్యాలెన్స్ చేస్తే for a set of questions you can have 1 mole of electrons transfer. 1 mole of electrons transfer చేస్తే ఎంత అమౌంట్ ఆఫ్ ప్రోడక్ట్స్ ఫామ్ అవుతుందో దట్స్ కాల్డ్ 1 Faraday. సో Mg+2 కి you need 2 Faraday to turn into Mg0 sort of that. Second law is the ratio of amounts of liberating amounts of different substances liberated by same quantity of electricity passing through. ఎంత అయితే డిపాజిట్ అయిందో దే ఆర్ ప్రపోర్షనల్ టు దర్ ఈక్వివలెంట్ వెయిట్స్. సో ఇప్పుడు Na డిపాజిట్ అవుతుంది అండ్ Mg+2 మెగ్నీషియం డిపాజిట్ అవుతుంది అనుకుంటున్నాం. యూ సెండ్ ది సేమ్ అమౌంట్ ఆఫ్ ఛార్జ్, సే 1 Faraday పాస్ చేసావు, దెన్ Na 23 grams డిపాజిట్ అవ్వాలి, Mg half the amount of it. ఎందుకంటే you need two but you only have one Faraday. So 20 is to 24. So 12 grams deposit అయితే. So it's like 23 by 12 is like 23 and 12 are proportional to equivalent weights. NAS equivalent weight is 23, C is 12. Okay, that example of one Faraday. So 2 Faradays తీసుకుంటే it's like 46 grams of sodium and 24 grams of magnesium. That ratio is proportional to the equivalent weight ratio of sodium and magnesium, which is 23 by 12. 46 by 24 equal to 23 by 12. Let's see second. Basically, conservation of mass and conservation of charge represented in a unique fashion. Products of electrolysis. నిన్న చెప్పిన galvanic cells thing. How do you say? దేనికి E like galvanic cell లో your E has to be more positive, right? ఎక్కువ E positive ఉంటే that will happen. If your electrolytic cells లో say water solvent ఉంది, water solvent లో you have H2O, H plus can convert into H2 and OH minus can convert into H2O and O2. ఇప్పుడు దానిలో నువ్వు ఎలక్ట్రోలైట్ డిప్ చేసావు, దట్ హ్యాస్ అన్ ఎక్స్ట్రా సెట్ ఆఫ్ క్యాటయాన్ అండ్ యానియాన్. సో ఇప్పుడు ఏ క్యాటయాన్ ఎలక్ట్రోలైజ్ అయింది, ఏ యానియాన్ ఎలక్ట్రోలైజ్ అయింది అంటే వీ హ్యావ్ సమ్ లాజిక్స్. ఎగ్జాంపుల్ NaCl ఇన్ వాటర్, ఇక్కడ చూపించిన ఎగ్జాంపుల్. At cathode there is a competition between Na plus and H plus. H plus 0, Na plus E is negative. Basically the reaction is not very supportive. Na stays more in rather than Na plus state than in. The reaction with higher value of E0 is preferred, and therefore the reaction at the cathode during electrolysis is H plus plus electron is half H2. Same logic, E positive ఉండాలి. So higher E0, the like it has a more tendency of happening. ఇక్కడ Na plus case లో your Gibbs energy turns out to be positive, so say non-spontaneous thing that won't happen. ఇక్కడ spontaneously ఉన్నప్పుడు you cannot push a non-spontaneous thing to happen. So your H plus turns into H2, and అలానే anode case లో let me continue. But H plus is produced by dissociation of H2, therefore net reaction is H2O plus electron is half H2 plus OH minus. H plus plus electron gives half H2 ని కోల్లాతో represent చేశారు. Usually convenience బట్టి you will use the 2.35 equation. At the anode, Cl minus and OH minus ionization are the reactions. E0 cell prakaram Cl minus has the highest, so Cl minus reaction అవ్వాలి. But there is a sorry, my bad. Your E cell is E0 cathode minus E0 anode. సో ఇప్పుడు E0 cathode ఎక్కువ ఉండాలి, E0 anode తక్కువ ఉండాలి. అప్పుడు E0 cell ఎక్కువ ఉంటుంది, delta G0 is more. On the basis of that, cathode కి ఎక్కువ like higher E0 ది cathode reactions లో you will pick the higher E0, anode reactions లో you will pick the lower. ఇక్కడ లెక్క ప్రకారం you will have your OH minus ionization. కానీ there is a concept called O potential. It's basically you need more charge and more voltages for the reaction to happen. అంత voltage ఇస్తే there are many side reactions happening and it's not very efficient. Okay, లెక్క ప్రకారం your OH minus should ionize first. Like OH minus should ionize first. కానీ when you are increasing when you keep the voltage to like 1.24, it's not happening. ఎందుకంటే it's happening very slowly that we can't see it. వోల్టేజ్ 1.24 వోల్ట్ లో పెట్టినా కూడా యూ కెనాట్ సీ ఎనీ యానోడ్ ఎలక్ట్రాలిసిస్. సో ఇప్పుడు ఆ ఓహెచ్ మైనస్ రియాక్షన్ విజిబుల్ అవడానికి యూ ఇంక్రీజ్ ది వోల్టేజ్ టు లైక్ కైనెటిక్ ఫ్యాక్టర్ ని సపోర్ట్ చేయడానికి వెన్ యూ ఇంక్రీజ్ ది వోల్టేజ్ నువ్వు 1.35 1.34 దాకా వచ్చినా కూడా యూ కెనాట్ సీ కన్సిడరబుల్ రియాక్షన్. సో అండ్ వెన్ యూ టచ్ 1.36 ఇంకా యువర్ OH minus reaction కాదు, your Cl minus reaction happens. Kinetic factor Cl minus కి బాగానే ఉంటుంది. సో ఇట్స్ లైక్ లెక్క ప్రకారం OH minus అవ్వాలి, బట్ ది రియాక్షన్ ఈస్ టూ డామ్ స్లో దట్ యువర్ Cl minus is getting ionized, like electrolyzed. So overall reaction, hydrogen will get electrolyzed, Cl minus will electrolyze. That's the below thing. You'll get H2 and Cl2. So this is one thing. This is another example of the same spot. H2SO4 key, those are the example reactions. For dilute sulfuric acid, the first reaction is preferred, but at higher concentrations, your second reaction is preferred. Same reason, no potential. Kani dilute case lo, you will have like no choice of it. No, wait, sorry. What do you say? H2SO4 lo, you will have like two cases. SO4 minus 2 ionization and H2 OH minus ionization. లెక్క ప్రకారం OH minus is preferred. SO4 minus 2 should turn into some O2 or something, I don't remember. Not the below reaction. So basically SO4 minus 2 is hard to electrolyze. So OH minus will get electrolyzed and first reaction will happen at dilute concentrations. Dilute sulfuric acid. కానీ concentrated అయితే you won't have enough OH minus, so your only option is SO4 minus 2 ionization. But it won't ionize ఎందుకంటే the ionization reaction కంటే this reaction has low E0 value. This SO4 minus 2 dimerization. Sulfate to thiosulfate. దీనికి E0 value తక్కువ. Low E0 value SO4 minus 2 ionization కంటే దీనికి తక్కువ ఉంటుంది. So these things happen. Please remember that. Batteries లో two types, primary, secondary. Primary are exhaustible batteries, secondary are recoverable, rechargeable batteries. Your phone batteries are secondary, your watch batteries are primary, your clock batteries are primary, your inverters are secondary. That's all. Primary, exhaustible ఎందుకు primary వాడతాం అంటే we can just use and throw these things. ఎక్కువ accessible గా ఉంటాయి. Like exhaustible. You don't need big arrangements. చిన్న వాటిలోనే you can contain energy. For example, your normal Nipo battery and your normal watch sets. Nipo battery పేరు LecLachie cell. చిన్న watch cells పేరు it's not Mercury. The descriptions are there. Most familiar example type is LecLachie cell. Cell consists of zinc container is anode and carbon rod is cathode, surrounded by powdered manganese dioxide and carbon black. The space between electrodes is filled by moist phase of ammonium chloride and zinc chloride. The ammonium chloride and zinc chloride phase serves as agar-agar solution, your salt bridge. between anode and cathode. Your anode is the zinc cup and cathode is the carbon rod. Uh, the electrode reactions are complex, but when simply written, that's all. Zinc turns to zinc plus 2 in cathode. Your, what do you say? Your MnO2 and carbon black paste is also serves as cathode. Cathode rod is like a storage supply. Your actual cathode is the MnO2 plus carbon black paste. Uh, zinc chloride serves the salt bridge thing. Cathode reaction MnO2 plus NH4 plus electron gives MnOH plus NH3. Which పెట్టుకోవాల్సినవి your zinc turns to zinc plus 2, that's oxidation. Mn plus 4, 4 reduces to Mn plus 3. ఎక్కువ ఊడ్చిపెట్టుకోవద్దు, దిస్ ఇస్ enough. ఎక్కువ ఊడ్చిపెట్టుకుంటే నీష్. సో దట్స్ ది లిక్లాషియస్ సెల్ థింగ్. mercury cells ki it's the following sorts. By the way, liclassier cell serves a voltage of 1.5 volt. It's not a steady voltage when compared to mercury cell. Mercury cell serves a very steady voltage for its lifetime. ఇప్పుడు leclassier cell is like your remote battery is best example. ఫస్ట్ లో బాగా పనిచేస్తాయి, తర్వాత when you hit the remote or something అప్పుడే పనిచేయడం స్టార్ట్ చేస్తాయి. బికాస్ when your cell starts to die off, దాని అది సప్లై చేసే వోల్టేజ్ కూడా తగ్గిపోతుంది. గోస్ లైక్ 1.5 to 0 very slowly. In your mercury cell, when your cell dies off, it just dies off. సో అది లైఫ్ టైం ఉన్నంతలో ఇట్ సర్వ్స్ ది 1.35 వోల్ట్ స్టడీలీ. అందుకే వి యూజ్ దట్ ఇన్ వాచెస్ సో దట్ ది టైమ్ డజంట్ గెట్ డిలేడ్. Batteries explain start just say it's an ocean of explanation for why we need a battery. So I'm just giving the final mercury cell. These are the your anode is the zinc mercury amalgam. Your cathode is a paste of HgO and carbon. That's the diagram. Your anode reaction is that, your cathode reaction is that. Same thing, what to remember. Anode ఇక్కడ కూడా your zinc is turning into zinc plus 2. Your cathode, your Hg plus 2 reduces to Hg. Remember this thing like MnOH. Secondary batteries problems వస్తాయి. Secondary batteries are two types discussed in NCERT: lead storage battery and your nickel cadmium cell. Lead storage battery runs essentially on sulfuric acid and see that your lead is the anode and lead paste is the cathode. Let me explain from start. It consists of a lead anode and a grid of lead packed with lead dioxide as cathode. So normal lead rods are anode, and much low they are lead plates and lead dioxide. They serve as cathode. And your electrolyte is your sulfuric acid. This electrode, lead electrode, is obviously not an inert electrode. It involves in the reaction, and your electrolyte involves in the reaction. This is the electrolysis thing. Cell reactions are as follows. your Pb turns to PbSO4, and at your cathode, your PbO2 turns to. Don't remember this one. Oh, remember the overall reaction. Your H2SO4 is getting breakdown when you're using your inverter. Mm. And when you're charging the inverter, your H2SO4 is being formed. And you need water. So inverters, you will often add water when it's charging. This is the reason. Uh, you'll need water in the reverse reaction. Basically, usage low, your H2SO4 gets consumed, recharging low, your H2SO4 gets formed. Your H2SO4 is like your energy content. In reaction with it only, it's a disproportionate reaction. That's about. Let's do it. Nickel cadmium battery, look at the cathode, change of charges. You need to. Nickel cadmium cell is expensive than lead storage cell. Your cadmium plate serves as anode, your nickel plate serves as cathode. చుట్టూ ప్లేట్స్ లా కవర్ అయి ఉంటాయి cadmium and nickel hydroxide. Lead storage thing, your Pb0 and Pb plus 2 is charging to Pb plus 2 is charging using this, and your H2O gets breaking. The reverse happens and charge. I apply the cadmium 02 plus 2 02 plus 2 plus 2 and yeah, that's and okay. Your fuel cells are essentially power generators, not your thermal power plants. Thermal power plants, so they are. This is like effective power. Your thermal power plants are based on turning chemical energy into mechanical energy into electrical energy. Your chemical energy is directly converted into electrical energy on the basis of theory of galvanization. So this is like a very commercial type of galvanic cell. Fuel cells are very commercial types of galvanic cells. The fuel cell they discussed in the NCERT is your water fuel cell. This was used in Apollo 11 or 12 spacecraft. So that's the cell. Those are the cathode and anode reactions. Cathode low, your 2 plus. If cathode low, your O2 plus H2O gives 4OH minus. Anode low, your hydrogen gets oxidized into water. Cathode low, your oxygen gets released into OH. The cell figure is not that much important. It's not that easy. So corrosion or rusting. corrosion is essentially rusting. Corrosion is a very broad word. Rusting ante it's just rusting of iron. Corrosion is very broad, but not gonna get into it. Corrosion, atmospheric corrosion is an example of your electrochemical reactions. See the figure, oxidation is your Fe oxidizes into Fe plus 2. Reduction is your O2, uh, your O2 reduces into H2O. Your atmosphere also oxidizes the Fe plus 2 to Fe plus 3. So you need your atmosphere in the like from the atmospheric oxidation, you are getting H plus for the reduction. You need atmosphere for rusting. Atmosphere లో ఉన్న H2O వల్ల H2 and O2 వల్ల your iron rust. Sorry, atmosphere లో ఉన్న O2 వల్ల when Fe and H2O come in contact, your iron rust. Fe2O3 is your rust. Fe2O3 is rust. Anode reaction Fe to Fe plus 2, cathode O2 to H2O, atmosphere Fe plus 2 to Fe plus 3. Now, that's the reaction first of all. That's how rusting happens. Prevention key, there are some ways. One of the simplest methods of preventing corrosion is to prevent the surface of metallic object to come in contact with atmosphere. So basically painting the metal. Uh, you can paint the metal or you can brush the metal with some chemicals, example bisphenol. Another method is I forgot the name. This another method is to cover the surface by other metals that are inert or react to save the object. But when you cover the surface of metal, your iron with an inert metal, it like it won't always prevent the iron from rusting. ఉన్న చిన్న holes నుంచి the iron will rust and before you know it the whole iron will rust. అంటే ఆక్సిజన్ అండ్ వాటర్ రస్ట్ రిపెల్లెంట్ కాకుండా ఇట్స్ బెటర్ టు హ్యావ్ ఏ rust attractor so that it will sacrifice itself to protect the rust. Sorry, iron. So the sacrificing method is called galvanization. So water, which metals attract water? Mg and zinc. Just example. And which metals repel water? Tin and zinc. I don't know. No, only tin. Tin repels water, so please don't cover your tin with iron. When you coat your Mg or zinc onto the iron, you will have what is it? The magnesium will get rusted off into some compound, but your iron stays safe. Okay, uh, that's where the projects go, like civil projects, these buildings, bridges. Below, you need your iron because iron is has a high tensile strength. Iron వల్ల structural rigidity పోకుండా ఉంటుంది సో ఐరన్ రస్ట్ పడితే ఇట్ గెట్స్ వీక్ అండ్ ది స్ట్రక్చర్ గెట్స్ బ్రోకెన్ డౌన్ సో ఎంజీ రస్ట్ అయిపోయినా పర్లేదు ఐరన్ నీడ్స్ టు స్టే ఎంజీ అండ్ మోస్ట్లీ దే యూజ్ జింక్ ఫర్ galvanization సో and the things here. I didn't cover some questions. Second question I discussed that. Fourth question I discussed that. Your sixth question. Let's storage that. Let me write the reactions. What's the question? Recharging reaction. So your H2SO4 is being formed. And మొత్తం reaction by. Let me write the discharge reaction. Discharge is E plus remember reaction గుర్తుపెట్టుకోక్కర్లేదు. You only have to remember that your lead 0 and lead plus 4 will be turning into lead plus 2 in discharge, and your H2SO4 is dying off. So discharge flow, the reverse is happening. Um, During discharge, so for plus 2. This is the formation of PbSO4 reaction, not the recharge reaction as a whole. You will have Pb plus 4 also. Basically, two electrons of transfer to Faraday will get 1 mole PbSO4. 1 mole PbSO4. You have here how much? 0.05 Faraday. So that is 1 by 4 1 by 40 moles. So 1 by 40 into weight of PbSO4 303, which is 7.6 grams of PbSO4. Again, please look at the conversions in the lead storage battery. This is not the whole equation above. PbSO4 formation के that's the equation. 10th question. 2 Faraday of electricity is being passed through a solution of CuSO4. The mass of copper deposited at the cathode is 2 Farad. Cu plus 2 uses to Cu plus 2 electron. Your SO4 minus 2 won't get ionized. Your anode reaction is your oxygen reaction. H plus 2, H plus 1 electron. This reaction is happening. Your anode reaction. So anode low H2O oxidizes to which two plus oxygen honestly reaction. Something O2 forms. So basically for 2 Faraday you have 1 mole copper. 1 mole copper is 63.5 gram. Last question repeated. Okay, 13th theoretical question. I'm gonna discuss some theoretical questions and 13th question and go to another set of questions. In the ultralytic cell, the flow of electrons is from. I didn't discuss. Uh, in the ultralytic cell, the flow of electrons from anode to. Okay, not in solution. That's wrong. Yes. Anode to cathode with external supply. Because anode is oxidation rate. Something else. Anode oxidation, so your electrons have to go from anode to cathode. Your reactions won't be happening, so you're applying an external voltage to make the reactions happen. So the answer should be, let me see. The answer is C apparently, cathode to anode to internal supply. Yes. Okay, my bad. In electrolytic cells, your cathode and anode are dipped in the same solution. Mm. You're supplying the electrons to cathode, so the electron moves from cathode to anode. Since you're um, this because you push this microwave. Another set of questions. Conductivity of alkaline solutions and their measurement. Molar conductivity of aqueous solution of sodium stearate, which behaves as a strong electrolyte, is recorded at varying concentrations of sodium stearate. Which one of the following plots are the correct representation of micelle formation in solution? Interesting question. Micelles formation theory. You have to know the micelle formation theory for answering this question. What happens in micelles is the very gist of it. Micelles is basically adding soap into water. మనం సోప్ ని వాటర్ లో కొద్దిగా వేస్తే ఇట్ వోంట్ మ్యాటర్, కానీ కొద్దిగా కన్సిడరబుల్ అమౌంట్ ఆఫ్ సోప్ ని వాటర్ లో వేసి వెన్ యూ లైక్ రబ్ యువర్ హ్యాండ్స్ ఆర్ ప్రొవైడ్ ఎనీ మెకానికల్ ఫోర్స్, ఫోమ్ వస్తుంది నొరగ. What happens there is, so let's say you're starting to add your soap into water. Initial your so basically the concentration, what do you say? Soap is sodium stearate, Na and something with stearate. This is a big organic molecule, Na plus and this minus. This is your soap. Uh, when you start to add soap, the concentration soap concentration ions. Initially, your concentration of soap increases, your concentration of ions increases. Kani after some time, when you add even more soap, your ions concentration will decrease. ఎందుకంటే there is a thing called micelle formation. It's basically form in ions అన్ని like Na plus and the stearate minus. The ions get together into some balls called micelles. Very big theory. Need like 15 minutes to say. Basically, your concentration of ions decreases, so your conductivity should decrease. Your molar conductivity, when you are seeing your conductivity and molar conductivity in the చెప్పిన loss, like concentration decrease అయితే conductivity decrease అయితే molar conductivity increase అయితే, that's for the concentration of ions. So ఇక్కడ first your concentration of ions increasing, your molar conductivity decreases. So the graph is like this. తర్వాత your concentration of ions increasing, so your molar conductivity increases, so the graph is as simple as such. Please see your ions, not So for this graph, the CMC is critical micelle concentration. It's when the micelles start to form, like the balls start to form, and when that's when your concentration, పెరగాల్సిన concentration తగ్గుతున్నట్టు. That's the answer. Second question, the decreasing order of electrical conductivity in the form of following aqueous solution. Formic acid, acetic acid, benzoic acid. Check the ionization. These all are weak electrolytes. So, ఏది ionic state లో ఎక్కువ stable ఉంటే that would be better. Like have high conductivity. HCO, HCOH. This is formic acid. CH3CO minus H plus. Benzoic acid. Sorry, acetic acid. What is benzoic acid? Benzene, OH, sorry, oic acid ion, H plus. These three are same. So ఇప్పుడు వీటిలో చూడాలి. Which one is more stable? This thing is more stable with your organic chemistry. Anion ki minus I undali. This thing is a minus I group. This thing is a plus I group. And దీని నుంచి you will have like resonance also, cross resonance. Benzoic acid ion anion, you will have like cross resonance also. And minus I కూడా ఉంది. I don't think you can consider the cross resonance. So this thing is more stable. So you will say benzoic acid more stable than HCOO minus more stable than H3CO minus I nothing plus I answer. So ionic state లో ఇవి స్టేబుల్ గా ఉంటాయి. సో యువర్ కండక్టివిటీ ఇస్ ఆల్సో దిస్ వే. C greater than A greater than B. Unfortunately, this is wrong. Formic acid లో there is a thing called equivalent resonance. I can't believe I forgot that. Equivalent resonance is your resonance structures are so equivalent that ఒక రెసిడెన్స్ స్టేట్ నుంచి ఇంకో రెసిడెన్స్ స్టేట్ కి షిఫ్ట్ అవ్వడం అన్నది ఈజీ. దట్స్ టు స్పీక్ ఇన్ ది కెనానికల్ మెథడ్. రెసిడెన్స్ హైబ్రిడ్ విషయంలో మాట్లాడితే యువర్ రెసిడెన్స్ హైబ్రిడ్ ఈస్ మోర్ delocalized in equivalent resonance structures. So unfortunately, HCO minus greater than your benzoate time. ఇక్కడ your resonance structures are not so equivalent ఎందుకంటే you have cross conjugation. ఇక్కడ you have sorry. So unfortunately, A greater than B and C. I bad. you will have minus I, but cross resonance disturbs the resonance of CO minus ions. Please remember this or understand this. Equivalent resonance, no resonance, cross resonance, and uh, cross resonance. So this thing is disrupted. So I will see. Last question of the day: which one of the following graphs between molar conductivity versus root C is correct? How am I supposed to answer this question? Your typical local answer equation minus A root C. Obviously, this thing is different for NaCl and KCl. And okay, there is one logic. So ఇప్పుడు BCలో B and C are not the answers because the A varies between NaCl and KCl. ఇప్పుడు ఈక్వల్ మోలార్ కండక్టివిటీ అన్నది ఇట్ ఈస్ హయ్యర్ దేనికి ఎక్కువ ఉందో వీ కెన్ సీ దట్. సో ఇప్పుడు యూ కెన్ హ్యావ్ Na plus ions and Cl minus ion and K plus ions and Cl minus ions. సో ఇప్పుడు చిన్న సైజ్ ఉంటే యూ హ్యావ్ హైయర్ మొబిలిటీ. సో NaCl కి యూ విల్ హ్యావ్ యువర్ డెల్ నాట్ ఎం higher. Na plus sorry NaCl greater than Kc. So your first graph is correct. And next question meda I did some questions yesterday. I didn't cover the corrosion part. Corrosion is essentially corrosion meda questions that it will be like one stuff. So I hope I have covered the one of the most important physical chemistry chapter and my favorite chapter with clarity. EYQs practice చేయండి and visit check the NTA app for more practice. NTA National Test Abhyas app only available in phone. So thank you.